In this video I'm going to talk about factorization. Now let's remind ourselves what factorization is. Well, let's take the number 24. It is a multiple of more than one number, so we can break it down into its factors. So we could write 24 as 4 times 6. So we have, one could say, factorized 24. Likewise, we can do factorization in algebra. Factorization of an algebraic expression. And we can do this when the terms in the algebraic expression have a common factor. So, for example, 2x plus 2y. Now the common factor here, let's have a look, is this one has a 2 and this term also has a 2. So if I put my equal sign and then put the 2 outside of the brackets, what goes then inside the brackets? Well, this first term here was 2 multiplied by x. So I've taken the 2 outside the brackets, I've factorized the 2. What's left is the x from the first term and then a plus y from the second term. Now we can do a quick check. I could just multiply the 2 back into the brackets, check that I get the same thing I had on the left hand side. This will give me 2x from the first, the 2 multiplied by the x, and then add 2y from the second, and we can see that we've got exactly the same thing here than we did here. So we have factorized this expression into this. So in general, one could say if you have something which is a factor which is common to both the first term and the second term, or indeed any of the other terms in the expression, you could put it outside of the expression and then put the rest inside brackets. So let's do a couple more examples. So we might be asked to factorize AB plus A. So let's ask ourselves the question, what is common to both AB and A? Well, this is A times B, so we've got 1A and 1B, and here this is just A, or A times 1. We don't normally write the 1 in front. There's an invisible 1 in front of the A. So what's common to both these two? Well, it's A, look. So let's take the A out the front, because it was common to both these two terms. Now what do we need to multiply AB by? What do we need to multiply A by in order to get back AB? Well, we need to multiply it by B, because if we multiply A by B, we get back AB. Then the second term, what do we need to multiply the A by to get back just A? Well, 1, because A times 1 is 1A, or just A. So we have factorized this expression into A brackets B plus 1. Or I could have written that A brackets 1 plus b. These two expressions are equivalent. Let's look at something slightly harder. Let us factorize this expression. Minus 4xy minus 12yz. Okay, well, what's common to both these ones? Well, let's look. This is minus 4xy. This is minus 12yz. We've got a 4 here, which is 1 times 4 or 2 times 2, and we have a 12 here. Let's look at the numbers. Is 4 a factor of 12? Well, yes it is, because we can write 12 as 3 times 4. So 4 is a common factor, and in fact negative 4, because it's negative 4 xy here and negative 12 here, so we can take out a negative 4, because negative 4 is common to both these two terms. This term has x, but this term doesn't have x. This term has a y, and this term also has a y. So y is common to both of them. And then this term is just minus 4xy, so there's nothing else here. This term has a z, but this one doesn't. So minus 4y is all that is common to both these two terms. So what do we need to multiply minus 4y to get minus 4xy? It's the x which is missing. Oops, sorry. And what do we need to multiply minus 12yz with to get... what do we need to multiply minus 4y with to get minus 12yz? Well, plus, because plus times a minus makes a minus, and that will give us the minus sign back here. We have a 4 here. We need to multiply 4 by 3 to get 12. We already have the y, but we don't have the z, so we have to multiply it by z. Let's do a quick check. If we multiply the outside term with the first term inside the brackets, we get minus 4yx, which is the same as minus 4xy, because the order of multiplication doesn't matter. And the second term becomes minus 4y times 3z, which is the same as minus 4 times 3 is 12, and y times z is z. So we've got the same, we've got back to where we started. This is equivalent to this. Now things start getting a bit tricky, because we have to use we can actually factorize quadratic expressions, things with squareds in. Let's have a look at that. In our last lesson, we looked at something called the conjugate rule. If you remember, if we had a product of two brackets like this, a plus b, all brackets, multiplied by a minus b, that gave us a squared from the first two, minus ab from this one multiplied by this one, and then plus ab from this one multiplied by this one, and then a minus b squared from the product of the plus b and the minus b. And these two cancel out, which left us with a squared minus b squared. This is a quadratic expression because it's got something to the power 2 in it. But if we were to go the other way, so to speak, we could factorize a squared minus b squared into a plus b multiplied by a minus b. from the conjugate rule. And this is a useful trick sometimes when, for example, you're solving quadratic expressions or quadratic equations. So let's do a few examples. Let's factorize, or attempt to factorize, x squared minus 25. Well, x squared is a square term, it's the square of x. Is 25 a square of something? Well, yes it is. We can rewrite this, x squared minus 5, made a mistake there, it shouldn't have been a squared, should just have been 25 there. Minus 25 is 5 squared. And this pattern is the same as the one you'll find in the conjugate rule. So this is, if you follow the rule here, working backwards, this is brackets a plus 5, close brackets, open brackets, x minus 5. Because something squared minus something else squared is the same as brackets a plus b, close brackets, open brackets, a minus b. Let's have a look at another example. 1 minus 4x squared. A bit trickier here. So, is 1 a square? Well, yes it is, because 1 times 1 is 1, or 1 squared equals 1. So that is just 1 squared. Is 4x squared a square? Well, 4 is the square of 2, 2 squared, and x squared is the square of x. So we've replaced 4x squared with 2 squared x squared. And if you remember, a squared b squared is the same as a multiplied by b all squared. So we can rewrite this 1 squared minus 2x in brackets all squared. And this is the result of the conjugate rule. So this becomes 1 plus 2x, 1 minus 2x. A bit trickier, that one. Now in the last example, we have to do some factorization first before we can use the conjugate rule. We have 5x to the power 6 minus 45y to the power 4. This is a tricky one, this one. So let's try factorizing this one first. Well, if we look carefully, there's a 5 common to both 5 and 45. This is 1 times 5, and this is 9 times 5. So if we take out the 5 out the front first, we're left up with x to the power 6 minus 9y to the power 4. Now, is x to the 6 a square? Well, yes it is. We can write it x cubed all squared, and minus 9y to the power 4 is also a square, because 3 squared is 9, and y squared squared is y to the power 4, so this becomes 3y squared all squared. And due to the conjugate rule, then I can now rewrite this x cubed plus 3y squared brackets x cubed minus 3y squared. That's pretty tricky. Let's talk about factorization of quadratic expressions. And this is important when solving quadratic equations. So let's ask ourselves, can we factorize the expression x squared plus 11x plus 18? Can this be factorized into something like x plus a x plus b? See if we can spot a pattern. Well, let's try. Let's take out the two brackets first. Now, how can we get x squared? Well, that's simple. The only way we can make x squared is having an x multiplied by an x. That will give us an x squared from the rules of multiplication of brackets. Now, we want to have 11x by multiplying x by something that goes here and adding then the product of something that goes here with x. And then we want to get the 18 by multiplying the 18 comes from multiplying the number that's here with the number that's here. Well, so let's take the 18 first. How can we make up 18? Well, 18 is 2 times 9, or we can write it as, well, let's prime factorize 18. 18 is 2 times 3 times 3. So 18 could be written as 6 times 3, 3 times 6, 2 times 9, 9 times 2, or even 1 times 18, or 18 times 1. Let's just try trial and error method to start with. Let's try plus 3 plus 6. Does that give us what we want? Well, that would give us x squared plus 6x, this thing multiplied by this, plus 3x plus 3 times 6, which is 18. If we combine the terms, this will give us x squared plus 9x plus 18. And what do we want? We wanted 11x. So that doesn't work. We've got 2x too little. Let's try again. So we can cross out this one and we can cross out this one. What about 2 and 9? Let's replace the 3 and the 6 with 2 and 9. So that will give me x squared plus 9x plus 2x plus 18. Combine the terms and I get x squared plus 11x plus 18, which is what I wanted. So we have factorized x squared plus 11x plus 18 into x plus 2, x plus 9. Brilliant. Let's do a few examples of some products of binomials. X plus 1 multiplied by x plus 2 gives me x squared plus 3x from the x multiplied by 2 plus 1x plus 1 multiplied by 2, which is just 2. So how did we get the x coefficient? X coefficient and the constant. Well, the x coefficient was this number here, 2 add 1, and the constant was 1 multiplied by 2. Let's take another example. X plus 4, x plus 3, that's x squared plus 3 lots of x plus 4 lots of x, that's 7x, plus 4 times 3, which is 12. So again, the x coefficient here is 4 add 3, and the constant is 4 multiplied by 3. So if we were to generalize this into x plus a, x plus b, then the x coefficient is always the sum of the two constant terms, or the two terms here on the outside of the brackets, a plus b, and the constant is the multiple of the two terms. So if something can be factorized, then the constant term is a product is the product of the two terms a and b, and the x coefficient is the sum of the two terms. So for example, can we factorize x squared plus 9x plus 20? Well, 20 we can write 1 times 20, 2 times 10, 4 times 5, minus 1 times minus 20, don't forget the negative numbers, minus 2 times minus 10, and minus 4 times minus 5. Now if I sum these numbers, 1 add 20 is 21, 2 add 10 is 12, 4 add 5 is 9, minus 1 minus 20 is minus 21, minus 2 minus 10 is minus 12, and minus 5 minus 9 is minus 4 minus 5 is minus 9. The only one of those which, when added together, makes our x coefficient are these two, look. So I know that my factors have to be x plus 4, x plus 5, because, let's do a check, when I multiply the brackets again, I get an x squared from that term, plus 5x from that term, plus 4x, plus 4 times 5, which is 20. Gathering like terms, that gives me 9x. I get x squared plus 9x plus 20, which is what I had in the beginning.